So number 1 was 1.176. 2 was 0.301. 3 was 2.079. 4 is 1.940. 5 is 2. 6 is 2.301. 7 is 2.875. 8 is 1.462. 9 is 2.890. 10 is 1.609. 11 is 4.605. 12 is 4.796. 13 is 5.886. 14 is 4.382. Let's see. 15 is 4.174. And 16 is 6.040. Yeah, I figured with this many decimals, it was going to be easier to just write them up so you guys could check. All right, so are we good with 1 through 16? Any questions on those? These were the ones you were just plugging in the calculator.
Like on the test, well, for number 4, I have 1.939. And I didn't round up to
You're fine as long as you're close. Like, I mean, I would prefer you to round it properly, but you're okay. All right. Okay, so let's move on. 17 to 22. So 17, you get 2 equals log base 6 of 36. And I had a couple people ask me, you can put like log base 6 of 36 equals 2. Like, it doesn't matter what side the equals thing is on. All right, so then 18, you get 2 equals log base 4 of 16. 19 is 3 equals log 5 of 125. 20 is 4 equals log 3 of 81. Savannah, would you mind to close that door really quickly? Sorry. Okay. 21 is 2 equals log 7 of 49. 23. Nope, sorry, 22. Getting ahead of myself. Is 6 equals log base 2 of 64. 23 is 3 equals log 9 of 729. And 24 is 4 equals log 8 of 4,096. All right, how did these go? Good? You guys feel better about it once you did a few of them? Putting the stuff in? Okay, good. All right, and then 25 through 32. So 25, you get 8 squared equals 64. 26 is 2 to the 4th equals 16. 27 is 3 to the 5th equals 243. 28 is 4 to the 4th equals 256. 29 is 5 to the 3rd equals 125. 30 is 3 to the 7th equals 2,187. 31 is 7 to the 3rd equals 343. And 32 is 12 to the 3rd equals 1,728. All right, so we are on page 344, 345, really. And we're going to go through all of these properties of logarithms that we'll eventually use to solve equations with logarithms. So the first one is called the product property. And basically what this one means is if you are taking the log of any two things that are multiplied together, 2 or 3, however many things. So let's say log of W times Z. You can separate that into the sum of two logs. So you can write that as log W plus log Z. So anytime you have multiplication that you're taking the log of, you can split it up to addition of two separate things. Right, and this also goes the other way. So like, let's say we had log X plus log Y. We could also, if we wanted to go the other way and condense it in, we could do log of XY. Right, so we're going to practice expanding them and condensing them down. Right, so addition and multiplication kind of go together. All right, questions with the product one? Okay, all right, so then the next one, very similar to this. Sorry if I go to the next slide. Everybody get that? Okay. The next one is the quotient property. So very similar to the product one, except this time we are dividing. So if we have the log of X divided by Y, any guesses on what that'll separate to? The other one was addition, so this one's probably subtraction. So it's just numerator minus denominator, so top minus bottom. And again, just like before, if you have something subtracted, you can write it as a quotient or a fraction. And we'll practice some of those in a minute. The other property we're going to use a lot of right now is the power property. And so for this one, so again, this works for logs, natural logs, whatever. So anytime you have an exponent, you can take that exponent out and it will like multiply to the front of your logarithm. So like it's going to come down here. So it's going to become 4 times ln of z. So exponents move to the front. All right, so let's go ahead and kind of practice expanding and condensing some of these expressions that are a little bit longer. So we'll like apply all of what we've got so far. All right, we go with this slide. Okay. So let's expand. So let's say we have ln of x squared times y. So the first thing we want to do is we want to break this up into two logs because we have two things that are multiplied together, right? So you always want to do your products or quotients first and then do the exponents last when you're expanding. So since we have x squared and y, we can rewrite that as ln x squared plus ln of y. And then since we have that exponent, we know to move it to the front. So our expanded expression would be 2 ln x plus ln of y. All right, so again, you want to do products and quotients first, and then exponents last. Okay, so let's do another expansion one. So for this one, we'll say we have log of the square root of xy to the third. So when you have a radical, you need to rewrite that radical as an exponent. So remember how we talked about like the square root is the same as the 1/2 power, cube root is the 1/3. You have to write it as its fractional exponent. So we're going to rewrite this as log of xy to the third to the 1/2 because it's a square root. Right, so if that was like a 5th root, it would be to the 1/5 power. You just make it 1 over whatever your index is. So there's really two ways you could do this. I think either one is fine. You can pull that 1/2, since it's multiplied by everything inside there, you can pull it to the front first and do it as like 1/2 log of x y to the third. But then when you separate that, you just have to make sure and keep that 1/2 with everything. So like you have to do 1/2 log x plus 1/2 log of y to the third. And then we still have to pull that 3 exponent down. So you would multiply that 3 times the 1/2. So then your final answer would be 1/2 log x plus 3/2 log y.
Why is the 1/2 from the radical? Is it just...
Yeah, well, because it's a square root, right? So like technically the index is 2. You can rewrite that as a 1/2 exponent. So like if it was a cube root, the exponent would become 1/3. Like what the index is becomes the bottom of it. Because we can't really work with the square roots, we've got to have everything in like exponent form for these.
What would the other one look like? Like this next two. How will you know what the index is?
Whatever number would be there. Like there's not one for 2, but any other time there is a number. Yes. Yes, Abby.
Can you just multiply the exponent by 1/2?
Yes. Yeah, so I just did 1/2 times 3 to get that 3/2. All right, questions on how to deal with the radical part of it. Did everybody see how I got that 1/2 exponent? Okay. All right, so let's practice going the other way. So we're going to take a longer expression and condense it down just to 1 log. So let's say our first example, we have log of 3x plus log of z. So what property would we use? Yeah, the product property, right? So that means we can combine those things together. So it's going to be like we multiplied this times this in our new log. So it would be log of 3xz. All right, so when you're condensing, the goal is to only have 1 log. So like log of something. All right, you should only have the word log or ln one time. All right, so then let's do another one. Let's do ln of 4w minus ln of y. So what property is happening here? Yes, quotient. So that means we will, this becomes our top number or our numerator, the y becomes the denominator. So it's going to be ln of 4w over y. All right, and then the last one, so anytime you've got a number in front, what is that going to become? The exponent. So we're going to like put it back here where it goes. So it would be log of x to the 8th. Okay, so that's condensing with just individual properties. So now let's do a long one, just so we can put it all together. So let's say we have the expression log base 3 of x. And for these, it doesn't matter what your base is. You just keep it with it. So like we've used log, we've used ln. This time we have log base 3. So our answer will just be like log base 3 of whatever. So that 3 doesn't really make a difference. It's just part of the log. All right, so for these, we're going to kind of go in the opposite order. We're going to put our exponents back first. right? So since we have coefficients here, we're going to make that a y squared. We're going to make this a z to the 5th. So we're going to kind of go backwards from the order we did for expanding. So we have log 3 of x plus log 3 of y squared minus log 3 of z to the 5th. Everybody with me so far with this part? All right, so then we're just going to kind of go in order from left to right. So like we have that addition first. So that means we'll condense these two and make this a multiplication. So we'll write this as log 3 of x times y to the 3rd. And then we just still have our log 3 of z to the 5th.
Why is the y to the 3rd?
Oh, it should be squared. Thank you. I got the 3 from that base 3 there. All right, and then since we have a subtraction now, we're just going to use our quotient property. And so we'll have xy squared on top, and then z to the 5th on the bottom. So now that expression is fully condensed because there's nothing in front of the log, and we've got just one log there. All right, so how do we feel about expanding, condensing? Pretty good?
The other ones were fine, but that one kind of threw me for a little bit.
Okay.
Because there's a lot.
There's more steps, right? Yeah, so the key thing with these is just kind of doing it piece by piece. So like always like the first thing I do is check if you've got any coefficients, put those as your exponents. And then like anything that's added together, so like even if there was like something added on the end, all the stuff that's added is going to be on the top. And then anything subtracted is going to be on the bottom of your fraction. So. Yeah, these can get a little tricky, but the more you do them and the more you use it, you kind of pick up on it quickly. So, all right, and then there's one last thing in this section I want to go over, which is the change of base formula. So this is what is going to allow you to like find logs. So like say log base 3, like you can find the log of something in a calculator with that. So again, that's called the change of base formula. So you can either use it with the common log or the natural log, it doesn't matter. So let's say we have log base b of something, right? So in order to do that, you can use the common log of your big number divided by the common log of whatever your base is. Like you can plug it in the calculator like that because these are in the calculator and you can use the common log. You can also do like ln of x divided by ln of b. So let's do an example because that's going to make it a lot easier to follow. So if we have log base 3 of 20 and we want to find that in the calculator, we can't plug in log base 3 into the calculator. So we would plug it in as log of 20 divided by log of 3, and that's going to give us the answer that we need. So when you do that, it gets to be roughly 2.727. And again, at this step, you can use log or ln, whatever button you desire. You will get the same answer either way.
When we put it into the calculator, do we do like the second and the thing, and then after you get your first one, you hit divide?
That's what I would do.
And then do you go back there and hit second and second again?
Yes.
Okay.
Yeah, or if you wanted to put it all in as one thing, I would just make sure I would just make sure and like put parentheses around the first one. If you're going to put it in all in one step. You should be fine even without that, but sometimes these calculators are picky. So, especially with logs. Abby and I learned that the other day. So, yeah, so you can either like get log of 20, get that answer, and then just hit divide by and then put in log of 3. Or if you want to like input it all as one thing, you could do it like that. You could even put it in as a fraction like this and it wouldn't give you that decimal answer. So, all right, so that's really it for this section. This is kind of a long assignment, so I've got the rest of today and tomorrow for you guys to work on it. Nope, it's under Thursday. All right. So on page 350, we're going 1 through 50 odd, or well, I guess 49 technically. Honors, I want you guys to go through 59. So again, we'll work on this today and tomorrow, because there's lots of them. And then Friday, I just want to review sections 1 through 4, and we'll have a quiz Monday or Tuesday next week.
On that last problem that we did, how did you put that into your calculator?
So let me go back.